thank you for being here, Zach. And I'm going to leave the stage to you now.
Awesome. Well, I'll say good morning to everyone. It's currently 4 a.m. Oh, sorry, 5 a.m. over in Australia. So you'll have to forgive me if I'm a little bit misspoken this morning. Still getting myself woken up. So consoles and beyond, making Bevy no STD compatible. So first off, just a little bit about myself, as Stefan mentioned, and again, thank you for the introductions. My name is Zach. You probably know me as Bushrat. That's my little user profile in the top corner there, if you recognize that. I'm an electrical engineer and a software developer, and I'm currently based in Tasmania. And my pronouns are he, him, for those that are concerned about that. So, onto the topic. But first, why no STD compatibility? That's the first question that I get asked when I start proposing this unit of work. But before I can answer why no STD compatibility, we should probably take a step back and actually define what no STD really is. But before I can do that, I want to go one step further back than that and actually talk about what the STD library actually is. I think we all have some preconceptions as to what the STD library is, especially if you are familiar with Rust from a long-term perspective. So we've got things like results, the box, print line, iterators, all the things that we use in Rust typically come from the standard library. But there's a little bit more complexity here that Rust hides behind the scenes from us. There's actually 3 smaller crates within the STD library. So if I take those same items and just sort them into those 3 categories, you can see that we've got something called core, something called alloc, and then something that's confusingly also called STD. Now, this isn't a comprehensive list. This is just a visualization of that breakup. So I want to go through what these 3 crates are first. So what is core fundamentally? This is the bare minimum functionality to get what most of us would call a Rust experience. So, and most things that are in the standard library, you'll actually find are in the core library instead. So this includes things like result, option, and even some of the more high-level abstractions like debug for printing, the iterator traits, most of the iterator combination methods like chaining and zipping. All of these things actually come from core. To kind of illustrate just how big core is as a crate, this is a screenshot from docsrs, and I've just drawn a little arrow up into the corner there. That side. To show just how long this list is. It's a huge crate. So then what's left? If core is so big, what's in these other crates? Alloc is the next one. Alloc, based on its name, is allocation-related functionality. So this is where we get things that need to interact with runtime memory. So boxes, vectors, arcs, reference counted pointers, basically anything that needs to touch the heap, if it's a more fundamental type, comes from alloc. Another important thing that comes from alloc is the actual allocator trait itself. So how a Rust program can ask for memory at runtime. And then finally, we then get STD. STD within STD provides operating system integration. So this is where we get some of the really high level functionality from Rust. So working with files, working with networking, multi-threading, time integration. A lot of that functionality then comes from STD itself rather than core and alloc. Time is an interesting one because we get duration from core. So we get the difference between moments in time from core. But to actually get an instant, you need access to the standard library, because to know what time it is, you need to ask somebody, and that somebody is typically the operating system. So with that overview, I can answer that first question. What is STD? It's core, alloc, and STD. So then following that, what is no STD? Just core and alloc. There's a bit of debate within the Rust embedded community as to whether you would say that alloc is a part of no STD. The reason why there's a bit of a debate there is that you can run alloc on any platform that supports core, but you need to provide an allocator. And normally, the platforms that you would run no STD code on are embedded type platforms where you just don't have a lot of memory to play around with. So why would you make an allocator if you've only got, say, 1 megabyte of memory to spare to play around with? For my purposes, I'm going to include alloc as a part of no STD, though. So with that sort of boring definitional stuff out of the way, why are we pursuing no STD? It sounds like we've got a lot of functionality in STD that Bevy would rely on. Obviously, files are how we get assets. Multi-threading, incredibly important for game performance. Why would we take all that away from Bevy? The important thing is that we're not taking these things away from Bevy. What we're doing is making them optional within Bevy. By making them optional, we can now take Bevy and make it compatible with a platform that does not have the option of providing that functionality. So the key here is that we're going to retain all existing functionality in Bevy. Nothing gets lost. But what we gain is new platform support that we previously just could not have. And I'll get into what kind of new platforms shortly. Another key benefit for moving to no STD is it's an opportunity to go back over old and established APIs within Bevy and refine them. This separation from what's STD and needs the operating system versus what's core and doesn't need anything, and what's alloc, where you need allocator functionality, that split pulls apart a lot of our existing APIs and exposes some really nice boundaries. And even though on a modern computer, you would have plenty of memory to work with an allocator, so you wouldn't need to care, for a game, allocation can be pretty expensive, depending on where you're allocating and why. So having that exposed and pulled apart makes it clear, oh, that bit of code has allocation happening in the middle of it because it needs alloc to work. So let's not use that bit of code in a hot loop. Let's pull that out off to the side. So stepping back, what kind of new platforms do we actually get access to with Bevy? Well, the typical that I've mentioned before is embedded platforms. So Arduino, ESP32, Raspberry Pis. These are the poster child for the embedded community within Rust. But there's a bit more to it than that. For example, when Rust gets ported to a brand new platform, think Redux for the Rust operating system, the standard library usually comes later than support for compiling in Rust. And the reason for that kind of makes sense. You can't have the standard library until you can compile in Rust. So support for compiling in Rust comes first, and then the standard library comes second. So for experimental platforms, that's nice. But that also includes platforms where getting a standard library made is actually quite challenging. For example, the current generation of consoles are supported by the Rust compiler. They're just x86 CPUs, so we can compile for them right now. But there's not a standard library crate, at least publicly available. There might be one privately available. I don't have an NDA to know that bit of information. So by removing that STD requirement, we've now got the possibility of compiling for those platforms straight away without any caveats. But those aren't actually the reason why I personally have started pursuing this initiative. The reason why I started pursuing this initiative is I had recently discovered that there are crates on crates.io for working with retro consoles. So if you look up crates.io right now, there's a crate called AGB, and that allows for compiling games for the Game Boy Advance. Not the Nintendo DS, not the Nintendo Switch, the Game Boy Advance. And I find that as a concept just absolutely mesmerizing, that Rust, this brand new language, not even 15 years past stable, you can take that same bit of code that we're writing for brand new high performance computers and just compile it all the way down to running on a console that's going on 30 years old now. That's incredible to me. But the Game Boy is not the only one there. There's platform crates for the PlayStation 1, PSX, and there's even crates for working with the Nintendo Switch, but in a homebrew context. So that one's called NX, or Nintendo Switch. Those kinds of crates allow us to compile and run games in very esoteric platforms, but they don't support the standard library. So if we could make Bevy no STD compatible, suddenly it's not just Rust that we've got available on those platforms. We've now also got a modern high-performance ECS-backed game engine and all of the community that comes with that game engine available for those platforms. And I find that, honestly, I'm stunned at the idea. I would never consider running, say, Unreal or Unity on a Game Boy or a PlayStation 1. But there's a distinct possibility of running Bevy on those platforms. And I think that that's a testament to the flexibility and power of not just Rust, but Bevy in particular. And then that last one that I've got noted there is just running on a computer, but with no operating system at all. So there's a platform crate called UEFI that allows for writing a bootloader in Rust and actually booting up onto a bare metal computer without Windows, without Linux, nothing. So if you're really wanting to prevent cheating in your game, I guess you could make a complete no operating system game in Bevy using this kind of initiative. So I'm hoping that's covered the why and the what, but how? It sounds like it might actually be a really challenging project to try and take a big game engine and make it compatible with such small, restricted hardware. But it's actually not as complicated or as challenging as I had initially expected, which is fantastic. There's really only a handful of things we need to do. The first is we just need to refactor some of our existing code. So the actual first fruits of this initiative was enabling a handful of lints that are already available in Clippy that just warn the developer, hey, you're using something from STD. It's actually from Core and Alec. Go use it from Core and Alec instead. And that's a very small change. It doesn't actually change the functionality of any code, but the important thing there is it highlights the places where we need STD versus where we're just happening to use STD because the name's convenient. So that bit of work has actually already been merged into Bevy and should hopefully be coming out with 0.15 when that comes out soon. So that's already done. We've got a nice refactor already handled there. The next major item is we still want to have ALEC and STD compatibility available to us. So we need to add features to all of the various crates in Bevy that re-enable STD and ALEC functionality. And then the last item there is dependencies. That one's a little scary because obviously we don't have direct control over all those dependencies. Those are their own projects. So it's a little rude for me to go over to a project and say, hey, you make yourself no STD compatible. But thankfully, the Rust ecosystem already cares a great deal about no STD compatibility. In fact, out of all of the crates that I've been working with Bevy right now, more than, I'd say 3/4 at the moment, are already no STD compatible. It's only a handful that are actually requiring STD. And even in that handful, a smaller subset of those don't have a no STD alternative ready to go. So where are we right now? Well, to get what I would call a bare minimum no STD functionality for Bevy, so something where a user can just cargo add Bevy to their no STD project, we need to have these 6 crates fully ported over to no STD compatibility. So these first 2, Bevy Pointer and Bevy Utils, they're already done. So that's why they're highlighted in green. The next 2 are Bevy Tasks and Bevy ECS. I've highlighted them in orange because the pull requests for making these no STD compatible are already published onto GitHub, and they're currently just waiting for 0.15 to release before they get fully reviewed and merged. Hopefully merged. I shouldn't speak too far ahead into the future. After that, it's then Bevy App and Bevy Core. Bevy App and Bevy Core comparatively are very small crates to get ported as well. So we are very close to having a bare minimum no STD Bevy experience. I don't want to commit to any timelines, but I am aiming for 0.16 to be a no STD compatible Bevy release. So if you're really interested in this functionality, I've got the ID of the tracking issue for a GitHub issue that I've opened up that just covers all of the little units of work, because this is really a lot of small changes that need to be made to Bevy, not one large change. One big pull request to make Bevy no STD compatible would be a nightmare to try and merge and get everyone on board with. So if you're really interested in some of the more technical details on how we're doing this and the progress we're making, I really encourage you to check out this tracking issue on GitHub. We also recently opened up a working group in the Bevy Discord, if anyone here is familiar with the working group system. So please check that out as well. Now, I've got a little bit of extra time here, and I've sped through this a little bit because I've got a couple of demos that I was hoping to show. So let's see if I get cursed with live demonstration woes. So I believe, yes, cool. Okay, I'm just double checking the stream to make sure that everything's all working. So this is a Bevy application that I've written that is completely no STD compatible. This is currently using a fork of Bevy that I'm working on that goes the extra mile and fully makes Bevy App and Bevy Core no STD compatible. And I really want to highlight that despite a couple of scary looking symbols up here, like, oh no, there's no STD, and why do I have entry written here? These, if you're from the no STD world, this is just the common parlance. We have to do some extra dancing to get Rust to play nicely on these platforms. What I want to focus on, though, is down here. We create an app, I add some plugins, and I run it. That Bevy plugin there is just a standard Bevy application. So add some plugins, set my runner, add some systems, order them appropriately. This is what I believe most people be familiar with when they think of what's it like to write Bevy. And so if I run this bit of code, give it a moment, this is a small Bevy application that is running on bare metal hardware, and it's opened up on my other monitor. So this application here, for those that aren't familiar with it, is QEMU. So this is running a virtual machine, and this is my Bevy operating system running on bare metal. and I've got keyboard controls, so I can speed this up, have this little Bevy logo bouncing around. I think that's amazing. That's fully controlled in Bevy. That's 100% Bevy code with one crate brought in to add compatibility with UEFI so that it can boot straight onto raw hardware. So I'm going to close that one. That keyboard shortcut. There's a second demo. I don't really want to show the code for it because it's a little, well, actually, no, I will show the code for it. I was going to say it's a little ugly because I only got it working last night. So this one here, it's another small Bevy application. It should hopefully look fairly familiar. We've got a plugin that I'm adding here, some resources, some systems, and then I run my Bevy app. This application is actually currently running right now. I don't know how well it's going to show up on the webcam, but it is currently running on a Raspberry Pi Pico driving a e-paper display. And it's probably too hard for me to show up on the screen, but down the bottom here, it is showing how much heap memory it's currently using, and it's using 63 kilobytes of memory to run this whole application. So I think what I want to illustrate with those is that this isn't a hypothetical set of features for Bevy. This is a very real and potentially very soon set of functionality for Bevy, if everyone wants it, of course. So with that, I would like to thank everyone for taking the time to listen to me. And I'll hand it back to Stefan there. Thank you all very much.
Hey, Zach, thank you so much. Amazing stuff. Yeah, I'm still flashed by seeing this Bevy logo on your Raspberry. Amazing. I can't wait to see Bevy rendered low level, I don't know, IoT stuff. Like this shows me basically that whatever screen we have, no matter how small or what kind of matrix kind of simple screen, we can run it and power it by Bevy, right? Yeah, we have a bunch of questions. They're voted for, so I'm going to start with the most pressing one, and then maybe if we can't get through all of them, we're going to talk about the rest in like a little panel conversation at the end, right? Mm-hmm. This is actually one that that is like 3 questions in one, and I'm also very curious about when did you start using Bevy? When did you start with the no-stud effort? And how hard was it actually to get into the code base to do this deep work?
Yeah, so I think I've been using Bevy for, I think I'd say about 12 months, I think now is probably a reasonable estimate, just as a hobby. So I'm not currently doing anything professional or any games anytime soon. Right now, I just love writing Rust, and Bevy is a great excuse to write a lot of Rust. So, and who doesn't like playing with games? I believe the second question was how hard it was to jump in, or
no. Let's start with when you started with the no-stud effort.
Oh, sorry, when I started with no STD. I believe that's only 2 or 3 months old now.
Wow.
So this is a very recent initiative. It started during the 0.15 release cycle, which is why it's not a part of 0.15. Well, not all of it. Some of the changes that I've made are in 0.15. So Bevy utils, for example, that's now no STD compatible for 0.15. So that's a new thing that's coming there. So the fruits of the labor are already starting to show up.
Nice.
And I believe the last one was how hard it was, or how hard it is. Amazingly straightforward. The biggest thing we have to do is annotate Bevy crates with no STD. And then the compiler says, well, if you're going to do that, and then highlights everything that's wrong. And it's a very mechanical process of just going through, okay, I can't use Vec here because I don't have the alloc feature. Okay, this requires alloc. Now it compiles. It's a very mechanical process of just going through Bevy and letting the compiler tell me what's wrong. The hardest things that we've had to change so far are there are a couple of core dependencies that Bevy relies on that aren't NoSTD compatible. The big one's ketgraph, for example. So we use that in the scheduler for organizing the order that systems are run in and making sure that it makes a coherent graph. That crate isn't NoSTD compatible. But making a NoSTD compatible alternative just for Bevy ends up not being too much work. It's around a few hundred lines of code added to Bevy to replace some of these dependencies. We do need to be pretty selective, though, about what we include. So Bevy render, for example, that relies on WGPU. That's not coming to NoSTD. There's a few things here where I draw a line in the sand and say, no, that's not happening. But the core functionality of Bevy, the ECS, the plugin framework, and then further from that, things like Bevy Color, Bevy Transform, a lot of the functionality that Bevy relies on, users of Bevy rely on, don't actually need the standard library. It just happens to use it because it hasn't been a problem before. Well, it's still not a problem, but I'm making it my problem.
But one follow-up to that. So you mentioned that once you see it uses something like VAC, you just slap alloc on it, right? But do you also come across places where you wonder, like, do we really need the feature XYZ here that makes us require alloc, and therefore, with a little bit more refactoring, it could get alloc free, or is that like a later problem once the first batch of work is sort of done?
That is exactly the kind of thing I was referring to when I was saying we get to refine some of our APIs. So it actually has been a couple of cases. So in Bevy utils, there was a little function that just shortens the name of a type to make the debug prints a little prettier. And that function needed string, and it needed to allocate memory in order to be able to take the name and shrink it down. But it actually didn't need to. With a little bit of refactoring, it could just write the short name from left to right without needing to allocate another string. So in that instance, didn't need to say, well, sorry, can't use it. You need the alloc feature. It was able to just refactor that little bit of code. And the big benefit there is now no STD platforms get to use that code. Yay. And on STD platforms, that code no longer allocates. So now it wasn't necessarily hot path code before, but it is more performant now that it doesn't allocate. Yeah. So both sides of Bevy get benefits from this initiative.
Yeah. That's really cool. Okay, I think we have time for one last question before we have to come back later. Not sure how serious that is meant, but I guess the underlying gist is clear. Has anyone run Bevy ECS on a toaster yet? And I think you already kind of showed the example at the end. It is something like that. Is there any other interesting use cases that you've seen that you didn't do yourself yet?
So I did see, I've seen some people mention the idea of making arcade cabinets using Bevy. You could do that with a full-size computer, but the embedded world has better support for working with things like joysticks and buttons and custom electronics. So I've seen that and think that's really cool. But I also have seen some people talk more seriously about the idea of, oh man, it'd be so nice to have the ECS framework for their little embedded IoT projects, like being able to use it as the scheduler and being able to use it to manage resources and everything. So there has been some interesting ideas that have been proposed, but I think this is something that's new enough as an idea that there isn't a fully fleshed out list of what can we do now? What does this unlock?
Yeah. Okay, gotcha. Yeah, that's so cool. So Zach, like I said, let's come back at the panel at the end for the remaining questions. I would like us to move on to our next speaker. Thank you so much, and I'm pretty sure you get a big virtual hand from the chat out there. And please keep the good work up. I can't wait to have more functionality being available in Nostode, and obviously the long-term dream of being able to port these platform-specific SDKs that will require us to have not a dependency on the Rust standard library. Thank you so much, Zach.
Awesome. Thank you very much for having me.